Think about your day. It's 24 hours long, right? We wake up, go to work or school, come home, and sleep. But what if your whole day was over in just 16 hours? Welcome to Neptune, the fastest spinning giant in our solar system. On this cold, distant world, days fly by in a blur. But how does a planet 4 times wider than Earth rotate so incredibly fast? And what does that speed do to the planet itself? Today, we read diving deep into the mysteries of Neptune's short day and exploring the science behind its wild, windy weather. Get ready for a journey to the edge of our solar system, where time itself behaves in a way you've never imagined. Neptune is the eighth and most distant planet from the Sun, orbiting at a staggering distance of nearly 3 billion miles. Out there, sunlight is faint, and the cold is unimaginable. Surface temperatures plummet to below -350 degrees Fahrenheit. You'd think a world this far out would be a quiet, frozen ball of ice and gas. But you'd be wrong. Neptune is one of the most dynamic and active planets we've ever seen. It's a world of violent storms, supersonic winds, and a mysterious internal heat source that keeps its atmosphere churning. A huge part of this activity comes down to one simple fact: Neptune spins incredibly fast. Its rapid rotation is a key ingredient in the recipe for its extreme weather, turning an otherwise frigid world into a chaotic and beautiful spectacle. So, when we talk about a day on a planet, what do we actually mean? A day is simply the time it takes for a planet to complete one full rotation on its axis. For Earth, that's about 24 hours. For Neptune, it's a mere 16 hours and 6 minutes. Think about that. If you could stand on Neptune's equator, which you can't, since it has no solid surface, you'd be moving at over 5,800 miles per hour, just from the planet's spin. That's more than 5 times faster than the speed of sound. This rapid spin has profound effects on everything, from its weather to its very shape. The planet is slightly squashed at its poles and bulges at its equator, a direct result of the powerful centrifugal force generated by its high-speed rotation. But why does Neptune spin so fast in the first place? To answer that, we have to go back to the birth of the solar system, over 4.5 billion years ago. Neptune, like all the giant planets, formed from a massive, swirling cloud of gas and dust left over from the Sun's formation. As gravity pulled this material together, the cloud began to collapse inward. This is where a fundamental law of physics comes into play: the conservation of angular momentum. It's the same principle you see when an ice skater spins. When they pull their arms in, they spin faster. As the gas and dust that would become Neptune collapsed into a smaller, denser ball, its rotation speed increased dramatically. And because there's very little friction in space to slow it down, Neptune has kept that incredible spin for billions of years. This high-speed rotation doesn't just make for a short day. It supercharges Neptune's atmosphere, creating the most extreme winds in the entire solar system. We're talking about winds that have been clocked at over 1,200 miles per hour. That's faster than a fighter jet. These winds whip around the planet, creating massive, continent-sized storms and dark, swirling vortices like the famous Great Dark Spot observed by the Voyager 2 spacecraft. The planet's fast spin creates a powerful Coriolis effect, which deflects moving air and organizes it into these powerful jet streams and storms. It's a perfect storm of ingredients: a rapidly spinning core, an internal heat source bubbling up from within, and a thick, turbulent atmosphere. The result is a world where the weather is more extreme than anything we can imagine on Earth. Now here's a mind-bending twist. While a day on Neptune is incredibly short, a year is unbelievably long. Remember, a year is the time it takes for a planet to complete one full orbit around the Sun. Because Neptune is so far away from the Sun, its orbital path is immense. It takes Neptune a staggering 165 Earth years to make just one trip around our star. That means that since it was discovered in 1846, Neptune has only completed one full orbit. So, you have this bizarre contrast: a day that's over in the blink of an eye, and a year that lasts for multiple human lifetimes. It's a powerful reminder that our concepts of time, days, years, seasons are completely relative to where we are in the cosmos. So let us imagine for a moment what it would be like to experience a day on Neptune. First, you wouldn't be standing on solid ground. You'd be floating in its thick, deep blue atmosphere. Sunrise and sunset would be rapid, spectacular events, with the day-night cycle completing in just 16 hours. The sun would appear as a tiny, brilliant star in the sky, about 900 times dimmer than it appears from Earth, providing only a fraction of the light and heat we're used to. The sky itself would be a stunning, deep azure blue, a color caused by methane gas in the atmosphere absorbing red light. And all around you, you'd feel the relentless, unstoppable force of the winds, a constant, high-speed roar that defines this distant, dynamic world. It would be a beautiful but terrifying experience. So, why do scientists care so much about how fast Neptune spins? It's not just a piece of planetary trivia. Studying Neptune's rotation and its effects helps us understand fundamental questions about our solar system. It provides a natural laboratory for learning how gas giants work. By observing Neptune's storms and wind patterns, scientists can refine their models of atmospheric dynamics, which can even help us better understand weather on Earth. Furthermore, understanding Neptune's formation and its rapid spin gives us crucial clues about the early history of our solar system and how planets like Jupiter, Saturn, and Uranus came to be. The speed of its rotation is an isolated fact. It's a key piece of the puzzle that connects its past, present, and future. And the importance of Neptune extends far beyond our own cosmic neighborhood. In the last few decades, we've discovered thousands of planets orbiting other stars, known as exoplanets. A significant number of these distant worlds are what we call Neptune-like or ice giants. They are similar in size and mass to Neptune and Uranus. By studying our own Neptune in detail, we gain a template for understanding these alien worlds that are too far away to see clearly. How do their atmospheres behave? Do they also have supersonic winds? Does their rotation speed influence their potential for hosting moons or even life? Answering questions about our Neptune helps us interpret the faint signals we receive from planets light years away, expanding our knowledge of the universe. In the end, Neptune teaches us a profound lesson about the nature of time and space. We are so accustomed to our 24-hour day and 365-day year that we think of it as universal. But it's not. Time is local. It's defined by the spin and orbit of the world you're on. On some planets, a day can last longer than a year. On others, like Neptune, days race by while the years crawl. This incredible, windswept, blue giant at the edge of our solar system is a constant reminder of the diversity and wonder of the cosmos. It's a world that never slows down, forever spinning in the cold, distant darkness, a testament to the powerful forces that shaped our universe. Thanks for joining us on this journey to the fastest spinning giant. If you love exploring the mysteries of space, be sure to subscribe for more deep dives into our amazing universe.